Good morning. Today we are discussing on oxides of nitrogen. So, nitrogen forms number of oxides in different oxidation state. Okay, so oxides are having different oxidation state. So, depending upon the oxidation state, different oxides of nitrogen can be obtained. Let us discuss one by one. First one is dinitrogen oxide. In case of dinitrogen oxide, the formula is N2O. Okay, so here we know oxygen is having -2 oxidation state and nitrogen +1. So oxidation state is +1, or we can write nitrogen 1 oxide. Okay, next common method of preparation. How can we obtain? It can be obtained from ammonium nitrate. Ammonium nitrate on heating, we will get N2O and H2O. Now, next, what is the physical appearance and chemical nature? Physical appearance of N2O is, it is a colorless gas and it is neutral in nature. Okay. Now, second one is NO, that is nitrogen monoxide. Here, the oxidation state is +2. Okay, so how can we prepare it? It can be obtained from sodium nitrate, then iron sulfate and sulfuric acid. All these compounds on reaction we will get iron sulfate, sodium bisulfate and 2NO and water. So, by this process, we can obtain nitrogen monoxide. Okay, what is the physical appearance? It is a colorless gas and it is neutral. Okay, now next third one is N2O3. N2O3 is dinitrogen trioxide. Here we can see that the oxidation state is +3, or we can write nitrogen 3 oxide. 3 represents the oxidation state. Okay, how can we prepare? It can be obtained from nitrogen monoxide and N2O4. N2O4, dinitrogen tetroxide, or these two on reaction at a temperature of 250 Kelvin, we can obtain N2O3. Okay, what is its physical appearance? Its physical appearance is a blue solid and it is acidic in nature. Okay, next is NO2, nitrogen dioxide. Okay, nitrogen dioxide, the oxidation state is +4. Okay, here the oxidation state is +4, or we can write nitrogen 4 oxide. Okay, nitrogen 4 oxide, nitrogen dioxide or nitrogen 4 oxide. Okay, how can we prepare this? It can be obtained from lead nitrate. Lead nitrate on heating at 673 Kelvin, we will get NO2, that is nitrogen dioxide, and PbO, lead oxide and oxygen gas is evolved. What is its physical appearance? Its physical appearance, it is a brown gas and its nature is acidic. It is acidic in nature. Okay, next one is N2O4, dinitrogen tetroxide, or we can write dinitrogen 4 oxide because its oxidation state is +4. Okay, see here the oxidation state, we get -2 oxidation state for oxygen, so -8. So here nitrogen is having +4 oxidation state. How can we prepare this? From NO2. NO2 on cooling we will get N2O4, and in reverse N2O4 on heating we will get NO2. Okay, next, what is its physical appearance? It is a colorless solid or liquid. And what is its nature? Its nature is, it is acidic in nature. Okay, now last one, N2O5. N2O5 is dinitrogen pentoxide. Dinitrogen pentoxide. Its oxidation state is +5, or we can write dinitrogen 5. 5 represents the oxidation state, 5 oxide. Okay, how can we prepare? It can be prepared from nitric acid, HNO3, P4O10. Okay, on reaction it gives HPO3 and N2O5 can be obtained. So, dinitrogen pentoxide is obtained. It is a colorless solid and it is acidic in nature. Okay, so these are the different oxides of nitrogen. Okay, so its appearance and its oxidation state. So different oxides are having different oxidation states. See, okay, so depending upon this oxidation state, different compounds are obtained. And here NO2 is less stable compared to N2O4. From the Lewis structure, we can identify that. Next, we are discussing the Lewis dot resonance structures of these different oxides. Okay. So these are the resonance structures. First one, N2O. See the resonance structure. Here N double bond N double bond O, N triple bond N single bond O. So here nitrogen valence electron is 5. Okay, and oxygen valence electron is 6. So if we see this, we can see 1, 2, 3, 4, 5. 1 electron from this nitrogen and 3 electrons from this nitrogen. So 3 electrons from this nitrogen, how many left? 2 left. Okay, so 2 electrons from here and 2 electrons from here are shared and form double bond. Okay, here 1 electron from this nitrogen and 3 electrons from this nitrogen forms here also one double bond. Okay, this will be the resonance structure. Here also the same thing. So here 2 electrons are here and 3 electrons are used for bonding. So triple bond. Here 3 electrons are used for triple bond. Then here it contains 6 electrons in the oxygen there. So the nitrogen gives both its 2 electrons to form a single bond. So this will be the resonance structure. And now the bond parameters. It is linear in structure and NN bond length is 113 pm and NO bond length is 119 pm. Okay. Now next NO, nitrogen monoxide. Here we can see oxygen is having 6 electrons. So 5 here and 1 electron is used for sharing. And here it contains 5 electrons. That means 2 already here and these 3 electrons are used for sharing. So they forms N double bond O. Similarly here. So here oxygen contains 5 electrons, odd number of electrons. But here the opposite case. Here nitrogen contains odd electrons. Okay. So 3 and 2 electrons are used for sharing. Here 2 electrons from oxygen are used for sharing. So we will get the structures like this. 2 structures are possible. So resonance structure. Okay. These are the 2 resonance structures. Now what about bond parameter? NO bond length is 115 pm. Okay. Now next formula N2O3. N2O3. 2 structures are possible. Here N double bond O, N single bond O. Here N double bond O. Here N double bond O are 2 corners and here one N single bond O. And at the center N single bond N. See here 6 electrons. So 4 electrons here and 2 electrons are used for sharing and here 6 electrons. And both the electrons for nitrogen are used for sharing. So nitrogen contains 1, 2, 3, 4. 1 electron here is used for sharing. And what about here? Here 1, 2, 3 from this nitrogen and 2 from this nitrogen. So total 5 electrons are used. So total 5 electrons, 1 electron used for sharing here and 2 electrons are used for sharing here. What about oxygen? 4 electrons left. So 2 electrons are used for sharing. Okay. Now here nitrogen gives 2 electrons to form covalent bond and here 2 electrons from this nitrogen and 1 electron from this nitrogen. So 1 electron from this nitrogen, 2 electrons left and 2 electrons from this nitrogen. So total 5. And what about this oxygen? 6 electrons are there. Okay. So 4 left and 2 used for sharing. Here also the same. 2 used for sharing, 4 left. Okay. And what about the bond parameter? NO 114 pm. This NO is one is double bond and one is single bond. Okay, 114 pm and 121 pm. And what about the bond angle? This bond angle NNO bond angle is 105 degree and this bond angle NNO, because this NO is different, so the bond angle changes 117 degree. Okay, then here this NN bond length is 186 pm and this ONO bond angle is 130 degree. So it is what is the shape? It is planar in structure. Okay, next NO2. Here nitrogen contains single electron. Okay, it is not paired. So from this we can see that it is less stable. Okay, if a atom contains unpaired electrons, that compound will be less stable. That we will discuss later. So it will dimerize and gets converted into N2O4. Okay, here oxygen 6 electrons already there. So 2 electrons from this nitrogen is used for sharing. Okay, 1 left and 2 from here. So total 1, 2, 3, 4, 5 electrons for this nitrogen, and here from this oxygen 2 electrons are used for sharing. Okay, next similarly here 4 here, so 2 electrons used for sharing. Okay, 1 electron left here, 2 electrons from this nitrogen form a double bond, and two electrons from this nitrogen used to form a single bond. So no electron from oxygen used for sharing. So it uses the electrons from this nitrogen for making it 8 electrons to make a bond with nitrogen. Okay, so these are the different compounds. So two more examples we will discuss. So here what is the shape of the compound? NO2 is angular in shape, and NO bond length is 120 pm, and ONO bond angle is 134 degree. So these are the different compounds. So two more examples, N2O4 and N2O5. Okay, N2O4, NO2 dimerizes and form N2O4. Okay, here these are the two structures. In this case, N double bond are on the same side and N double bond here are on the different side. These are the differences of these two resonance structures. Okay, see, these two nitrogen uses all its 5 electrons for bonding. See, here 2, here 2 and here 1. So 5 electrons used for sharing. Similarly here also. So these two nitrogen also uses all its electron for sharing. Okay, this oxygen 2 electrons, this oxygen 2 electrons, then these two oxygen used its 2 electrons for sharing, and these 2 electrons uses the electrons of this nitrogen for bonding. Okay, next similarly here also the same condition. Okay, now next here the bond parameters. Here the structure is in planar in structure, and CONO angle is 135 degree, and here the bond length, NN bond length and NO bond length are different. NN is 175 pm, NO is 121 pm. So this is the first one. Next N2O5. See the bridge structure, NON structure, and 2 oxygen are on the opposite sides. Here 2 oxygen are on the same side. These are the differences of these two resonance structures. See, here it uses 2 electrons. 1 electron from this oxygen and 1 electron from this oxygen used for sharing. Then 1 from this nitrogen, 1 from this nitrogen. So then nitrogen uses both electrons for sharing. Then here nitrogen uses these two here for making double bond. So all the 5 used by this nitrogen. Here this nitrogen also uses all its 5. Similarly here also. Okay, next, so the structure, bond parameter, its a structure is planar in structure, and see here ONO bond angle is 134 degree, and NON bond angle is 112 degree. Then NO bond length is 151 pm, and this NO bond length is 119 pm. So these are the different oxides of nitrogen, its oxidation state and its different resonance structures and shape. Then bond parameters, we discussed all the different properties of these oxides of nitrogen. Okay. See, there is a question, why does NO2 dimerize? From the Lewis dot structures, we saw already the two resonance structures of NO2. See, here 1, 2, 3, 4, 5. These are the 5 electrons. So here it contains one odd number of electrons present. Okay, valence shell contains one odd number of electrons. Due to this odd number of electrons, they are less stable. Okay, so they tend to pair these electrons. So in order to attain that pairing, they dimerizes and form N2O4. N2O4 contains even number of electrons. Even number of electrons. Okay. Here it contains odd number of electrons due to this reason. Okay. So NO2 gets dimerizes and form N2O4.